So today we move to the chapter 2, and as you can see, the title is Fluid Properties. Okay, so today, most important thing is the fluid properties. Okay, so this is outcomes for these chapters. So the chapter 0.1, we are focused on system and the state and the properties. Because when we have the problems, so we need to understand what kind of system we have, okay? So we need to define the system first. And then we try to understand what is the state. Some kind of the state, many states, maybe sometimes is a steady state, and sometimes is isothermal process. So the different process, we have the different state, and we need to understand what kind of the condition we have. Okay, so finally is the properties. So if we move to the next, so totally we only have the 8. We only have the 8 fluid properties we'll teach in this class. So totally we only have the 8 common fluid properties. And today I will introduce all of the fluid properties today. And one of important property is density related topics. Okay, as I highlight the sentence here, usually for fluid, we always consider the density of the fluid is constant, didn't change, okay? Even though the different environment conditions, but the fluid always has the constant density. But as I said before, the fluid includes 2 materials. One is gas, another is liquid. So the constant density only satisfies for the liquid, but the gas can be changed the density. Okay, so I will provide more details in later. Okay, and then the next, we are focusing on the stress. And as I mentioned, there are 7 common fluid forces. So in this chapter, we have 2 topics. One topic is we have 8 fluid properties. Another topic, we have 7 fluid forces. Okay, so one most important equation we call that is viscosity equations. And sometimes we are discussed with the viscosity equations. There is important conditions. We call that the no-slip condition. Okay, and I also will teach you in the later. And the final topic, 2 topic, is the surface tensions and the vapor pressures. Okay, so it's quite simple. If you look the slide showing here, I just put one example here. As you see the diver in here, and what are the system for these problems. So the system includes all of the material you see in slide. That means the system is include the diver first, and the surrounding area is water, right? And there is the gas tank, and maybe here is the controllers for the gas, right? So the system's not difficult to understand because the system just what you see. You see the diver first and the surrounding waters, and there are some gas tank and the gas controllers. Okay, just your systems. And then the interface between the diver and the surrounding water, we call that the boundary. because sometimes we have the problem, so we need to understand what's the boundary, and maybe we can provide the boundary condition for our problems. Okay, and for hydrology, you can see this is the river, the channel in here, and then sometimes we will conduct the flume experiments, try to better understand the river process in laboratory. Because usually we go outside, especially the season is typhoon coming, and the environment is too dangerous, right? It's very difficult to observe the situation for the river process. So sometimes we do the river process in laboratory. And then if we can understand and figure out some physical phenomena, and we can go outside to look at the result. Okay, so for this experiment, the system is the river channel in laboratory, and the water and the air condition, right? So the total systems is not difficult to understand by yourself. Okay, so what is the state? As you can see, the right-hand side here, this is the state 1. And we can call that the state 1 is before the compress. And the state 2 is after you do the compress first. And then you can have some recorder to measure the pressure, temperature, and the volume change during you conduct these experiments from the state 1 to the state 2. Okay, and you can see what are the temperature changes, what are the pressure changes, and then what are the volume of the gas changes. Okay, so usually from the state 1 to the state 2, we call that the process. And the process can under different conditions. So the famous condition, we call that the steady state. So the steady state is the properties of the system are constant with the time changes. That means that there is no any physical properties change with the time. So we call that the steady state. Okay, that means from the state 1 to the state 2, the density didn't change. So we call that the steady state. The physical property density didn't change with the time, with your process. Okay, and sometimes we may conduct the laboratory experiments and we fix the temperatures. That means from the state 1 to the state 2, the temperature didn't change. So we call that the process is isothermal process. Okay, and then another we call that the adiabatic process. That means there is no heat transfer between the system and the surrounding areas. Okay, so as I mentioned, the boundary is between the system and the surrounding, right? So the heat cannot transfer cross the boundary. Okay, so we call that the adiabatic process. So for me, I usually pick up this, the steady state, because this is very famous for our problems. Okay, so what kind of the property we will learn from today? I emphasize totally we have the 8 properties related to the fluid. So sometimes the property can be distinguished in 2 parts. The property related to the kinematic and the property related to the materials. So as I highlight some important kinematic parameters here, such as the precision, velocity, and the accelerations. So these are very normal parameters related to the kinematic. And the material, we may have the viscosity, density, and the specific weight. But as I mentioned, totally we have the 8 fluid properties today. So here only 3. So the next slide, I just summarize all fluid properties and merge to one slide. And then you can count how many properties we have So this is the first one, the density, right? And this column here, the column showing here is totally related to the density. Okay, so the first one is the density, and the second one is the specific weight. As I mentioned, the specific weight is gamma and equal to rho g. So we have the density and multiply the gravity constants, so we can have the gamma specific weight. And you see, the third property is we call that the specific gravity, Sg. So Sg is divided by the ratio between the densities. So the upper is any fluid densities, and the bottom is the density for the water. So Sg is the density relatively to the water density. Okay, and you can multiply the additional gravity constants, and then you can transfer to the gamma, right? Okay, so totally we have the three fluid properties related to the density. The first one, density, right? And the second is specific weight. And the third one is specific gravity. Okay, so you need to remember the specific weight is gamma, and the specific gravity is Sg. Okay, so the four properties is the dynamic viscosity. I always emphasize the viscosity is very important properties in our class. Okay, so the 5 is the kinematic viscosity. So you can compare two parameters. Only one difference is the kinematic viscosity is defined by the dynamic viscosity divided by the density. So the difference, the mu is dynamic viscosity, but here kinematic viscosity is defined by the mu divided by the rho. So the one difference here is the rho. Okay, so it's very easy to understand, because as I have the force, force is the dynamics, right? Force is the dynamic, and the force is equal to the mass multiply the acceleration, right? If I divided the force by the mass, and the answer is equal to the accelerations. So the force, usually we call that is the dynamic problems, but the acceleration is the kinematic parameters. So that's why dynamic viscosity here is mu, right? After we divided the dynamic viscosity by the density, and then we call that the kinematic viscosity. OK， 所以我们粘滞系数有两个，一个是动力粘滞系数，一个是运动粘滞系数。那这中间只差在一个 density。那通常 density 里面就会有质量。哦，所以动力跟运动之间通常都只差在一个质量。你把它除掉以后，它就会变成 kinematic。OK。If you divided the density and the dynamic parameter will convert to the kinematic parameter. Okay, so until now we have the 5 fluid properties already. And the 6, we call that is the bulk modulus. EV, the bulk modulus. The bulk modulus is a parameter to understand the compressibility of the fluid. Okay, if the bulk modulus is larger, that indicates the material very difficult to compress. So the volume can be changed. Okay, if the bulk modulus is smaller, that means your material is easy to compress, and the volume will be changed. Okay, and then so I just highlight the compressibilities. It's very important for our fluid material. And then the final two, the 7th, and the 8th, we didn't teach today, will be teach in next week. But the final two also important. One is the surface tensions, sigma, and the vapor pressure, PV. Okay, the final two parameters are also important. So this slide just merge all of the fluid properties in one slide, and totally we have the 8. Okay, totally we have the 8 fluid properties. Okay, so again, summarize. The first one is the rho. The first one is the rho, and the second one is the gamma, and the third one is Sg, mu, V, EV, sigma, and the PV. Totally 8 fluid property. Okay, so this is one example. That's for the English unit in Z. And then, based on these figures, please find out the dynamic viscosities of the gasolines. And under the temperature condition is the 150 degree F. So based on this table, you need to focus on the x-axis. The x-axis here is the temperatures. And the y-axis here is the dynamic viscosities. But you need to find out where is the gasoline line. So this is for the gasoline. Okay, this line is for the gasoline in here. Okay, in here. And the upper, you can see for the upper line, as what I mentioned is for the line here, you can see the trend is decreasing when the temperature increases, right? The viscosity is decreased. The mu decreases when the temperature increases for this part. And at the bottom, you can see a little increase. The mu a little increase when the temperature increase. If you take a look more details, the bottom lines for the material is the gas. The upper is for the liquid. So that means that they are the fluid, but the one is liquid, another one is the gas. But the trend for the viscosity related to the temperature are different. For the liquid, the viscosity will decrease when the temperature increases. But for the gas, the viscosity will increase a little when the temperature increases. Okay? And then the second conclusion is the viscosity for the gas is always smaller than the liquid, right? Because all of the line for the gas are lower than liquid. Okay, so two important things is that there are different chains for the liquid and the gas material. And the second is the viscosity of the gas always smaller than the liquid. Okay, but go back to our questions. So we know the 150 degrees F is here. And then we know the line for the gasoline is this line. Okay, so we would like to find out the viscosity for these conditions. So we can draw the line and the first to here. Okay, so we find out the viscosity number is the 4. And you check the different 10 powers. Okay, so finally we know that the dynamic viscosities for the gasoline under these temperatures is the 4 multiplied 10 minus 6. And the unit here is the English unit. Okay, so usually for our exercise or example or quiz, you don't need remember the viscosity. I will provide the table or the number for our exercise. Okay, but you need some different properties you need to remember. As I mentioned, the gas and the liquid, they are a different chain for the viscosity as function of the temperature. And the viscosity for the gas always smaller than the liquid. Okay, so you need to keep in mind two important properties, but you don't need to remember the numbers of the viscosity. Now, for our exercise, usually I will provide the numbers and also provide the table, and you can check out by yourself. Okay, so this is one very important figures, and because not all people buy the textbook, so for the table or for the figure showing here, we'll upload to the E3 website. So you can download the figure and the table from the website if you didn't buy the textbook. Okay, I already upload the figures in our E3 website. Okay, so just one example, we can do exercise. Okay, so the question here is, what is the specific weight of the air? Okay, so we know that the material is air. And under the temperature 20 degrees and under the 3 atmospheres pressures. Okay, so what's the problem here? The problem here is the specific weight gamma for the air, right? So this is our unknown parameters. Okay, we didn't know these parameters gamma A. And we know that the temperatures, we have the temperatures, T is 20 degree. And the pressures, because they emphasize this is gauge pressures. What is the gauge pressure? It's the pressure related to the environment. As we know, the environment pressure is 1 atm, right? And the gauge pressure is relative to the environment pressures. So absolute pressure is the 1 atm plus 3 atm. OK， 这个我们之后才会教到。通常我们说 gauge pressure 就是表压力，表压力是我们测量到的嘛。那测量到的压力一定是相对于一大气压的压力是多少，所以我们真正的绝对压力其实是还要把一大气压加回来。我们在思考问题的时候是要思考绝对压力，不是表上的压力。OK， So that's why we plus the 1 atm, because the gauge pressure is relatively to the environment pressures. Okay, and as I highlight, for 1 atm, the 1 atm is equal to 101.3 kilopar. Okay, so we can convert the atm to the par. So the 4 atm multiply the 101.3, and the k par is 3 powers, and the par, the unit is the par. Okay, so you can calculate by your calculators. Sorry, I forgot bring my calculator. 到底你有吗？没有记忆的吧 ？Okay, so you can compute by yourself. So the answers for the pressures is the 405 to 200, and the par, the unit is actually newtons per meter square. The newtons per meter square. Okay, I use the dot here. Okay, and here we know that the gamma A is equal to the rho AG, right? So for this problem, we still didn't know the rho A. So maybe we need to compute the rho A first, and then we can compute the gamma A later, right? So how can we have the rho A? So if you see the hint I highlight here, if we have the ideal gas law, and based on the ideal gas law, maybe we can compute the density, right? So based on the ideal gas law, so our problems, we have the ideal gas law. So we know the equations is the P equal to rho R T, right? So our purpose is low, so we can just move the RT to the left hand side. So the pressure divided the RT is equal to the rho. Okay, and then for the ideal gas law, the temperature we need to convert to the absolute temperatures. So here we convert the temperature to absolute temperature is the 273 plus the 20 is equal to the 293 K, right? Okay, and then one hint I highlight for the airs, the specific gas constant for the airs here. So we have the 287 is our gas constants. So we write down all of the values we already know. The first one is the pressure. So we have a 3. We have the pressure is 405,200 newtons meter square, and divided the R. R is the gas constants. So I divided the R is the gas constant. So 287 over 1, and the unit is the joule. The joule is the newton multiplied the meters, and divided the kg multiply k, and because this is on the bottom, so the unit is a newton meters, and the kg, the absolute temperature k, and divided the T is the 293 over 1, and the unit is K over 1. Okay, so we can balance the unit. Some unit we can cancel out, like the K and Newton and Newton. So the final unit is the kg divided the meter cubic. The unit is homogeneous, right? The unit is equal to the density unit. So the dimensional is no problems. So we just finally use the calculator to compute the final density. So the density is around the 4.82. It's around, okay? And if you consider and figure out these numbers, if you remember if the air under the room conditions is equal to 1.2. So why we have the larger number in here is 4.8, right? Because we do the compression force. We have a compression force, right? It's the pressure, the environment pressure is 1 atm, but right now we increase to the 4 atms. So the material on the air will compress. So that's why the density will increase. Okay? So as I mentioned, you have the answer and you need to figure out is correct or not. So this number is satisfied to our problems. But the final purpose is the gamma. So what is the gamma? The gamma is the rho g, right? So the rho g is equal to 4.82 multiplied by 0.81. Okay? And if you balance the unit, this is a kg meter cubic multiply the meter and the second square. Okay? So use your calculator to compute the final answer. It's around the 47.27 and the Newton divided the meter cubic. So this is our final answers. Okay, so that's a problem very easy, just to figure out. You need to understand your condition first. What are the condition for this problem is the temperature and the pressures. So your air under the temperature and the pressures, so the density will be different, right? And the density difference, so when we compute the specific weight also difference. Because specific weight is the gamma equal to rho g. So the rho difference and the gamma will be different. Okay, so this is a very quite simple idea. So the words I highlight here. So you need to, why the density will become larger, because we do the compression force. Okay, so this is the first one. We practice how to understand the physical properties. And the table 2 summarizes the fluid properties. The first is the density, gamma, and the Sg, right? And the equation also defined here and here. Okay, but you focus on this table. The table just tells you the temperature and the pressure effects for your properties. As you see, for the density, when temperature increase, and the density will decrease. It's very easy to figure out, right? Because the temperature increase, so the volume of the materials increase also. And then the density will decrease. Okay, but if you see, if the pressures increase and the density will increase also, that's also, again, your material under compression environment. So the material volume becomes smaller, and then the density will increase. But this is only for the gas. And the bottom here is for the liquid. So for the liquid, the density, if you focus on the temperature increase, the density also decrease, right? But as I mentioned, for the liquid, it's very difficult to compress. So for the liquid, the density didn't change with the pressures. As you see the sentence showing here, the density didn't change when the pressure changes for the liquid. Okay, so you need to focus on some important thing is for the gas and the liquid. The property for the temperature and the pressure effects are different response. Okay, so you need to focus on here. And I don't need to emphasize the gamma and the Sg again because they are the same as the density. Okay, so I don't need to repeat explain. 所以这个表格大家要特别注意的是，它在跟你讨论不同的 property 受到温压的影响。那不同的温压对于 gas 跟 liquid 的影响还不一样哦，所以要自己注意看一下。那 for density 的话，最重要的就是液体跟气体受到压力的变化是不一样的。气体是可压的，液体通常不可压。Okay, so the next, this is very difficult, so you need to wake up here. So you see for the viscosity mu. Okay, and the temperature increase, the mu for the gas, the temperature increase, and the mu also increase. Mu is viscosity. So the reason why for the gas, the temperature increase and the viscosity also increase, because for the gas, there is no any certain interaction force between two gas material. So if the temperature increase, the system energy will also increase. If the system energy increase will provide the particle start to motions. So the gas material will collect together more frequently. If the gas material compaction together more frequently, that means the viscosity will increase. Okay, that's why the temperature increase, so the viscosity will increase. But for the liquid, the temperature also increase, but the viscosity is decreasing. Because for the liquid, we have a certain interactions force between two liquid materials. If your temperature increase will broken the connection force between two liquid. If the connection force broken, so the liquid particle can move freely. And if more movings, that means the viscosity is decreased. Okay, so this is also only focused on the temperature effect, but for the gas and the liquid are totally different trend. So you need to keep it in mind. And for the pressure effects for the viscosity are independent. So you can see are independent. That mean the viscosity didn't change with the pressures. The viscosity didn't change with the pressures. No matter you are focused on the liquid or gas, didn't change with the pressure changes. Okay, and we move to the next for the kinematic viscosity. As I mentioned, the kinematic viscosity is defined by the mu divided the rho, right? This is for the kinematic viscosities. So for the gas, we already know the temperature increase, the mu will increase, right? But for the gas, we know the temperature increase, the rho will decrease, right? Any material, if the temperature increase, the density will decrease. So you have decreased densities. And you go back to figure out what the kinematic viscosity changes. Because the rho increase, the mu increase and the rho decrease, so the final will increase, right? The kinematic viscosity will also increase. So you see here, for the gas, the kinematic viscosity will increase. Okay, this is for the gas. But if we look for the liquid here, as we know, for the liquid, the temperature increase and the mu will decrease. But for the liquid, when the temperature increase, the rho also decrease. So we cannot figure out the kinematic is increase or decrease, right? But so for that part, you need to keep in mind will decrease. The kinematic will decrease. 这里的话，因为密度也减少，然后动力粘滞系数也减少，所以其实我们没办法直觉去分辨它要减少还是增加。但是结果是减少的，所以这个大家可能就要用记的。Okay, so for the liquid, the temperature increase and the kinematic is decrease. But for the pressures here, I already emphasized for the liquid, the density didn't change with the pressures. Okay, so they are the independence. I highlight the independent here. But go back to see the gas here. The pressure increase, if the pressure increase and the mu didn't change, right? Based on the result here. But the pressure increase and the density will increase also, right? For the gas. And the resulting, because the density increase, but the mu didn't change, but the density increased. So finally, the kinematic viscosity will decrease. So the result here. And if you have the textbook for the table is wrong, the result is wrong. So 你们可以看到这个箭头特别奇怪，是我后置上去的。教科书里面的这个 table 是错的，它是说是增加的，但是实际上是减少的。这个大家要记得。教材里面的教科书是错的。Okay, so a little bit complex, but you need to keep in mind some property change with the temperature and the pressures, and especially for the gas and the liquid may be different. Okay, so you need to figure out by yourself. And then the following is the surface tensions and the vapor pressure, and the final one is the bulk modules. I will teach you in the later, in the following class. So if you forgot something important I highlight here, you need to look for here. I just highlight some important things you need to remember from the tables. So the certain definition for the kinematic viscosity, and you can find the law using the ideal gas law, and look up the law changes with the temperatures, and you can calculate the kinematic viscosity by yourself. Okay, so two tables show add fluid properties, and the fluid properties will have some response to the temperature and the pressures. So you need to keep it in mind, okay? And this table just highlights some important gas properties for the air and the carbon, helium, hydrogens, methanes, and the nitrogen and oxygens. So you can see the different airs have a different kinematic viscosity, different gas constants, different densities. So for the air, you need to keep in mind that the air, the density is around 1.2. And the previous slide showed the one exercise, we do the compression force. So the density increased to 4.8, right? So this is a normal density for the air. And some nitrogen and oxygen, they are different densities. And the final two thermal properties is one is we call that is specific heat, specific heat, and the K in here is adiabatic exponent K. It's divided by the Cp divided the Cv. Because we can measure the specific heat under different conditions, we can under the constant pressures or under the constant volumes. And under different conditions, we will have a different specific heat. So two important parameters is the C and the K. The two parameters related to the thermal problems. In our class, we are not focused on the thermal problems, but you need to keep in mind some thermal important parameters, K and the Cp. Okay. And then this is a table list for the air properties. For the air properties, and you can see the different temperature. This temperature increase, and the density decrease, and the specific weight also decrease. And for the dynamic viscosity is increased, and the kinematic is also increased. Okay, so this table you can double check and compare with the previous tables. The property changes for the viscosity with the temperature increase. You can double check from the table showing here. Okay, so 那我们差不多就休息一下好不好？几个比较重要就是这几个表格，然后几个特性，随着温压的变化，大家一定要记得啊，不要去背，就像我刚才是用想的，用它的定义去想思考它，这是一开始的基础，所以这没有办法。我们大概休息10分钟。